Hello everyone and welcome to the VMware Online Fundamentals webinar, and today we're dealing with Zero Trust Security, securing the digital workspace. So we're going to be having a look at what Zero Trust Security is. We'll define what Forrester says it is, and we'll also look at how we can bring the Zero Trust Security model to the digital workspace. So today in the agenda, we'll be covering the anatomy of an attack, and we'll have a look at a couple of examples of attacks and some security breaches that we've seen in the headlines recently. And we'll also have a look at how we can bring Zero Trust or make Zero Trust work in the digital workspace. And we'll have a look at four of the key attack vectors, so users, applications, endpoints, and networks. And then we'll look at how we can really accelerate Zero Trust using analytics and automation. And then at the end of that, we'll have a look at how we can bring all of this together into the digital workspace. So we've seen quite a lot of attacks, hacks, security exploits in the news over the past couple of years. Some of the big ones out there have been WannaCry and NotPetya. And also Spectre and Meltdown. So WannaCry and NotPetya, they were ransomware attacks, and what they did is they got a susceptible user to access an attachment, and then via that attachment, the malware would then encrypt the underlying operating system of the machine, and then it would come up with this really helpful page which would ask the user to pay a certain amount of Bitcoin to get the ability to decrypt their operating system and then get access back to their data. And we saw a lot of WannaCry across a whole range of different sectors. So we saw it a lot in healthcare, where potentially whole hospitals were being held ransom. And a lot of organizations did pay to get their data released. And then on a slightly different vector, there was Spectre and Meltdown, and this was based on particular vulnerabilities which were hard-coded into Intel and AMD CPUs. But these are just a number of different malware headlines that we've seen recently. And I think probably more concerning is not necessarily that we're seeing more of these, but it's the fact that we are still struggling to control these different security breaches. And we have some pretty horrific figures when it comes to the impact of these breaches. So probably the scariest statistic is the fact that it, on average, takes 206 days to identify a security incident. Now, if you think about the amount of data that can be stolen from an organization in 206 days, then it's obviously quite a lot. And we're seeing 250,000 new malware registered every day, and that was back in 2017. So with the acceleration of cyber threats and the proliferation of internet-attached systems, you can see how that would be increasing in 2019 and into 2020. And then the average cost of a data breach is $3.62 million US. And that's before you take into account the GDPR rules that came in last year, which means that organizations can be fined a big chunk of their global turnover if personally identifiable information is breached. And recently there's been a couple of examples of large organizations who have been fined hundreds of millions of pounds because they have lost personally identifiable information. So it's critically important to make sure that any solution, especially when it comes to the digital workspace, any solution that is implemented within an organization is completely secured. And some of that security, or a big chunk of that security, will come down to how you protect the users, how you protect the endpoints, how you protect the applications and the devices that were vulnerable to Meltdown and Spectre. You can see that Apple actually released patches reasonably soon as soon as these exploits were found. But then even 4 months after those patches have been released, we're still seeing large numbers of devices that hadn't been patched. And probably the interesting stat here is the fact that enterprise devices were actually found to be more vulnerable because they hadn't been patched. And there could be a couple of different reasons for that. It could be that enterprise devices, especially iOS, tend to have a longer life in the enterprise, so refresh cycle maybe 2 to 3 years, whereas in the consumer world, you may replace an iOS device every 12 to 18 months. But it still showcases how enterprises really haven't necessarily got on top of patching vulnerabilities and applying updates to their devices in the organization. So I'm going to use a real world example here. So we'll go into an attack in a little bit more detail. So in this case, we had a retail organization, and they were actually using VDI in the back end. And if you think about how VDI works, you'll have a user potentially connecting externally and then connecting into a VDI server or a virtual desktop that sits in the data center. Now, in this case of the retail organization, that VDI session was compromised. And even though the user recognized that something strange was going on, the user of that VDI session recognized that something strange was going on and reported it to IT, they reported it on a Friday evening before they left for the weekend. And then what happened was this malware managed to get access to a whole range of different systems within the data center. So this VDI server was in the data center, and because there were no lateral controls between any of these different services, it was quite the attacker was quite easily able to get access to a whole range of different services. Now, it wasn't that IT wasn't on the ball with this. So if you have a look at when exfiltration of data started, it was soon after the machine was exploited. And even though security response began at 8 p.m., there was still a large amount of data which had been exfiltrated from the organization. So in this sort of attack, in this sort of scenario, what could IT have done? Well, I think it's worth having a look at what the background is to these sort of attacks. And I think a lot of it comes down to the fact that users now have completely new expectations when it comes to being able to work on devices. And users, ever since about 2007, when Apple introduced the iPhone, users' expectations have changed dramatically. They no longer expect to come into, let's say, an office and sit at a table with a PC under the desk and use that PC and use the services from 9 till 5 and then leave for the day. They expect to be able to have access to their applications and their services 24/7 from any location. So it's these flexible work styles that are making it quite difficult or challenging for IT to be able to apply the traditional security models that they would have applied in the past. And when you think about it, what's happened is the perimeter has dissolved for most organizations. And instead of having the safety of perimeter security, so firewalls to prevent any malicious attackers from coming in, now what you tend to see is that because you have your data on multiple devices, on multiple ecosystems, on multiple applications, and potentially on multiple networks, 3G, 4G, wireless hotspots, it gets much more difficult to be able to, one, get visibility of what your users are doing, and two, to be able to secure what your users are doing once they're outside of your traditional security perimeter. And it's because of this that the whole idea of zero trust was created. So at its simplest, Forrester's zero trust model of information security, it's a conceptual and architectural model for how security teams should redesign networks into secure microperimeters and strengthen data security using obfuscation techniques, limit the risks associated with excessive user privileges and access, and then dramatically improve security detection and response with analytics and automation. So at its heart, it's about creating perimeters instead of these traditional wide perimeters that you get around a traditional network, a traditional LAN, and a data center. It's about shrinking these perimeters and then controlling individual applications and devices. And that's at the core of everything that we're doing with the digital workspace. So how can we take this, these micro perimeters, the zero trust model, and then apply it to the digital workspace? Well, again, let's have another look at these attack vectors. When you think about a digital workspace, you have users, you have endpoints, you have the network itself, and now you have a whole range of different application ecosystems that you have to secure. And you'll have users who may traverse international boundaries. You'll have a range of endpoints. You may have iOS and Android and Windows. Your applications may be SaaS applications. How do you secure SaaS applications? And then you may have information being accessed on a device which is potentially in a different country and being accessed through a 3G data network. How do you secure all of these different components? Well, the answer that we believe is Workspace ONE. So Workspace ONE is a platform that's been designed with security in mind from the top down. So while we provide a really consumer simple experience, and the idea is that your users can access all of their applications, all of their data, and all of their services through a really simple to use app store, and self-provision their own applications as well, so that it's transparent to the end user. So what they see will be an easy way to access the App Store, an easy way to get access to their applications from any location. But then from the IT perspective, you know that that device is actually secured, or the application is secured, or we know for sure that that user is who they say they are, and we are giving them access to the applications they should have access to. And that's what it comes down to. We protect the consumer simple employee experience, while at the same time ensuring that you still have security across all of your different ecosystems. And we do this through using identity, so users' identity, and also by using context based on the device and the ecosystem. Excuse me. So what that means we can do is that we can provide a really industry-leading user experience. Whatever application ecosystem your users are using, we can control those applications. We can control the underlying devices. And because this platform sits in a really unique location, if you think about it, every device and every user and every application in the organization goes through this platform, we're in a unique position to pull back a lot of different insights. And then from those insights, we can actually set up different tasks, different automated tasks based on what that user is doing, based on the context, and based on the status of the device. And this is very, very powerful. So if we have a look at users first, so when it comes to user management, obviously you support the traditional directory approach to having a single source of truth for your users. But then we can also manage credentials, and we can manage user provisioning. And then when it comes to authentication, obviously you want your users to be able to have a really easy way of accessing all of their different services, whether or not that's SSO, so the ability to get access to all of their applications from a single login, or if that's through a particular application that maybe doesn't support SSO, so password vaulting or multi-factor authentication. Everybody these days has mobile devices, so you can use that as another form, another factor of identification. And then for all of the different service providers that are out there offering SaaS-based services, so the ability to provide SAML authentication or WS Federation for Microsoft Office 365 or OAuth or OpenID. All these different ways of providing really easy access, but still secured and verifiable access to different services. And then when the users are actually authenticated as who they are, then deciding whether or not they should have access to certain services based on the context, based on their context, based on their device status. So if we focus on SSO for a moment, and this actually is an incredibly critical security play, because when you think about it, one of the biggest issues that we've seen in traditional IT for a long, long time is that a user may have multiple services to access. And when you think about SaaS applications, this becomes doubly apparent, because you may well have on-premises applications secured using Active Directory. You'll have an Active Directory username and password. But then when it comes to SaaS applications, you may well have so many different services that each service will require a different username and password, a different set of authentication credentials to put in. And what you tend to see when a user has to deal with multiple passwords, multiple lists of passwords, is that they then become a security vulnerability themselves. They may use the same password across multiple services, or even worse, they may write their passwords on a post-it note and then stick it to the bottom of their keyboard. And obviously that's an incredibly large security risk. So when it comes to single sign-on, the ability to just use either a single username and password, or even a thumbprint, or any other fingerprint, or biometric, or facial recognition, or two-factor authentication, or token-based authentication, the ability to use a single route to access all enterprise services for that user means that those passwords are not being written down, that you're not having a single set of passwords or a single password being used on multiple services. So with SSO access, not only are you providing really, really good user experience, but you're also protecting the organization from having passwords breached. And then when it comes to accessing these different services, obviously, as I mentioned earlier, users may have, most users will have a mobile device. So what makes sense in that case is if you decide a certain application or a certain service needs to have multi-factor authentication, so on top of biometric or instead of biometric, you can actually use the platform to ping up a response on another device. So if you try to access a particular application, you'll then be prompted on the other device to grant access. And this is another really intuitive way of allowing your users to get access to their services without having to remember a password or write down passwords. So if we have a look at a really key security piece of the platform, conditional access, this is where you can start to see how powerful the security components of the platform are. So let's say you have, or a user has, a managed device and they're in a particular network scope. So let's say you've assigned network scopes to particular locations. So this could be HQ. You could say if the device is managed and enrolled in Workspace ONE and it's within HQ and on the HQ subnet, then that user is allowed to get access, and they can get access through thumbprint. So they get access to all their applications through a thumbprint. We trust the device. We trust the location that device is in. But potentially that managed device is then taken to a Wi-Fi hotspot. And that is not a recognized network scope. In that case, we could say, well, okay, we still trust the device, we still manage the device, but we don't necessarily trust the network. So in this case, we're going to require multi-factor authentication, potentially VMware Verify. So to get access to applications, which would have been through a simple biometric ID in HQ, when that device goes out of the network, we then require an additional level of authentication over and above what they required at the office. And then if the device is jailbroken and out of network scope, we can say, well, no, you can't have access to any application or any service. You can actually set it up so that a jailbroken device is not allowed to have access to any enterprise applications. And for obvious reasons, if a device is jailbroken, then it could be compromised in a whole number of ways. But when it comes to conditional access, we have a whole host of different granular controls you can put around different applications to specify what authentication level that user needs to have, what device platform they need to have, which network scope they need to use to get access to that particular application. So it can be incredibly granular. And the other attack vector could potentially be the applications themselves. So when it comes to applications across a whole range of different ecosystems, we can actually plug into the applications themselves, into the APIs, and we can protect those applications. We can make sure the applications themselves are using DLP technology, so that if it is enterprise-grade email, then we can prevent any attachments being taken out of that email sandbox and opened in a non-managed application, or being removed from that device altogether. And the same when it comes to browsing, and the same when it comes to content. And Workspace ONE itself actually includes secure productivity applications. So VMware Boxer, VMware Browser, and Content Locker, these are market-leading solutions when it comes to getting access to enterprise level services. So in the case of Boxer, you have access to all the APIs and all of the security controls right there in the Workspace ONE console. So you can be assured that all of the emails the user is accessing and all of the attachments, maybe sensitive attachments, are fully secured and are fully locked down. And all of this is controllable from the Workspace ONE platform. So endpoints is obviously a really, really large attack vector, because if you think about a modern enterprise, there's going to be a lot of different entry points into the organization through the whole range of different devices that may be deployed. So if you the type of capabilities you'd expect to have against these endpoint devices, if you think about encryption, then through the UEM platform, the Unified Endpoint Management Platform that is Workspace ONE, we have the ability to set encryption against a device. So this could be a mobile device, or it could be Windows 10. We have the ability to set the encryption level, password complexity. So these are traditional MDM type tools that you can set to make sure the device is fully secured. And then when it comes to compliance, again, as I mentioned earlier, if the device is compromised in any way, you can lock down what access that user has or that device has to certain services. And you can say, well, if that device is compromised, then I need to push out a new compliance profile. If that compliance profile gets pushed down and the device gets remediated, then I will start to allow access to applications again, all in a completely automated manner. If for some reason that compliance profile doesn't get deployed against that device, then I will carry on stopping that device from having access. And then configurations. So we have integrations with the likes of Windows 10 App Locker. So you, with pretty much any enterprise device, you can whitelist and blacklist applications. You can stop users from getting to the enterprise, getting to the public app store. So the Apple App Store or Google Play. You can set up tethering. And then when it comes to data and applications, we have full control of DLP access for pretty much every enterprise application out there, including Office 365. So we can simply plug into the available APIs, and then we can protect those applications, and more importantly, protect the data that's in those applications. Another way that enterprises tend to access data, especially Win32 applications, is through virtual Windows desktops and applications. And interestingly, virtual Windows apps and desktops have been around for a long, long time, so around about 20 years. And the biggest use case for accessing virtualized Windows applications and desktops has always been security. And the reason why this is a secure method of accessing these services is because the virtual applications and the virtual desktops stay in the data center. Everything that touches the endpoint, whether or not that's a laptop or a mobile device or a thin client, there is no data that's left on that endpoint. So all you actually have going across the network is simply screen changes, and you have the ability to interact with a session. Once that session is finished, there is nothing that remains on your desktop. And you have the ability with the Workspace ONE platform as well to be able to lock down all of the key sharing features you'd have in a Windows desktop. You can stop copy and paste. You can stop your users from being able to take a screenshot of what's going on. You can stop them being able to take files and folders across onto their local client. So using virtual apps and desktops, you have built-in security when it comes to Windows and Win32 applications. The other big attack vector is when it comes to networks. So if you think about the whole different range of networks that are available, from 3G to 4G to wireless hotspots to Wi-Fi signals in a hotel or on a train, then you need to be able to guarantee that the network that is being used isn't compromised, and to do, or if it is compromised, to make sure that the data that is traversing that network is completely secured. So one of the things that we can do with Workspace ONE is we can actually set up a tunnel, a per application tunnel from each of your endpoints. So when you launch an application, so let's say you have an application on an iOS device, and that application needs to access a particular service that sits in the data center, you can actually set up a tunnel that will only access that particular service. So by doing this, it means that that application has no access to services which it isn't allowed access to. So potentially it could be a HR application on a mobile device. A HR user accesses that application, and then using Tunnel and using other VMware technology, it means that that application will only ever access those HR servers or services back in the data center, and won't have access to finance or sales or other employee information. And that means that that application, both on the device is sandboxed, but also on the traversing a network and in the data center is completely sandboxed. So if we go back to that that scenario we saw with retail earlier on in the presentation, if a digital workspace, a secure digital workspace platform had been in place, then potentially that user, that malicious attacker who had attacked that VDI session, wouldn't have been able to traverse lots of different services in the data center, and they would have been limited to just that one service. As I mentioned earlier, Workspace ONE is in a very, very powerful position inside the enterprise, because When Workspace ONE has been deployed strategically, every device will be controlled and managed via Workspace ONE. Every application will be delivered via Workspace ONE. Even SaaS applications, if you're accessing a SaaS application, identity management will be via Workspace ONE. And that means every application, every service, and every user touches Workspace ONE on a daily basis. And that means that Workspace ONE has the ability to take a lot of information and to aggregate it. And the capability we have in Workspace ONE to do this is called Workspace ONE Intelligence. And what that will do is it will take all this information, so potentially logs from each of these different devices, so iOS, Android, desktop machines. It will take user activity information. If it's a SaaS application, then we can see when the user accesses the SaaS application, we can take contextual information, but all that information is brought together and we aggregate all that information into a data lake. And then we give you the ability to run reports against it. Now, about a year to 18 months ago, we acquired an organization called E8 Security. And one of the things that gives us the ability to do is to leverage the whole idea behind user and entity behavior analytics, or UEBA. And UEBA is seen as an evolution of traditional SIEM technologies. And what UEBA will do is to give you the ability to spot when a user does something out of the ordinary. So if we can baseline user behavior, and if we can see what they do as normal day-to-day behavior, if they start doing something outside of what is normal for them, then the platform, the UEBA capabilities built into the platform will then flag that up. And so straight away, you'll be able to see if that user is doing something out of the ordinary. And this is important because if you remember, that most scary statistic right at the beginning of this presentation was that on average, security breaches were ongoing for 206 days. If you could stop that happening within an hour of that user starting to do something they don't normally do, or even potentially even less time, then you can severely limit or even stop data being exfiltrated from the organization. And that's why this is a really powerful capability that we're building into Workspace ONE. So let's have a look in a little bit more detail at Workspace ONE, Workspace ONE Intelligence, and see what it looks like in practice. So you can see here the Workspace ONE Intelligence dashboard, and in here I've got a lot of visibility when it comes to a whole range of different devices, so pretty much every device in the organization. I can also have a look at applications, I can have a look at security risks. If I want to, I can create reports that give me the ability to have a look at, in real time, at update statuses across a whole range of devices. So if I was to create a dashboard just looking at Windows updates and to find out how many devices had been patched recently, I could even select a particular device platform. I could select individual Windows updates, and I could then run that report against all of my Windows machines to see which ones have actually been patched. I can then drill down and have a look to see which of those devices have the patch installed, which ones are have the patch available but not installed, which have failed, which would obviously be quite a worrying group of devices, and also which have been rolled back. And I can I can customize the dashboard as well. So I can see total device enrollments, I can see the total number of applications, and I can change the look and feel to match my own preferences. So one of the really cool dashboards, I think anyway, that we have built into the platform is a default dashboard called Security Risk. And this will flag up all of the key information that you'd want to see straight away across your estate. So compromised devices. Obviously, if you have any compromised devices, you want to get on top of that straight away. Passcode risk. If you have devices which aren't matching your password compliance policies, you want to get on top of them straight away. Same with encryption. And then if you want to, in all likelihood, if you do find a device that doesn't match one of your policies, you want to be able to take automated actions. And that's where the automation capability built into intelligence comes in really, really powerfully. So let's say with that initial report, you found a machine, a Windows machine that required an update. What you could do is you could plug into a third-party communication tool, in this case Slack, and then you could get that to send a message to the end user to say, hey, you don't have this Windows 10 patch, we're going to deploy it to your machine and it will reboot, just beware. And then we can also plug into other tools to make sure the patch gets deployed. So, and also in this case, to create a ServiceNow incident so that IT has full visibility of what's going on. And then once that incident type has been created, and then that's been plugged in, we can then go through the Workspace ONE actions. And if you have a look at the bottom here, you'll see that one of the actions that we could deploy in this case would be to schedule an OS update. So using Workspace ONE, using the intelligence, the analytics, and using the automation engine that's built in, we can find the device that doesn't have the update. We can send a message to the end user saying you're going to get this update. We can then create an IT incident, so IT are aware that this machine didn't have the update and that we intended to push the update out. And then we can integrate with Workspace ONE, the UEM platform itself, to push out the required update. So all of that would takes place automatically without IT involvement, which again is very, very powerful, and it does cut down on IT overhead. But we also make sure that any machine that doesn't reach security compliance, we can remediate that very, very quickly. And another key part of the platform is the fact that we can integrate with a lot of specialist security vendors, and we call this the Workspace ONE Trust Network. So by doing this, we can build on top of the platform that we have in Workspace ONE. Workspace ONE is by its nature a secure platform that's easy for end users to use. But we do recognize in some occasions it makes sense to integrate with third parties. Some customers may already have these third parties in the organization, and that's why we have the Trust Network. And this is a selection of security partners that we integrate with. So we have access, or they have access to our platform. And then when it comes to Workspace ONE, you can actually select these platforms, and you can select to integrate with the platforms. Have a look here. So this is a sort of a Carbon Black example. You can see that Carbon Black is running in the background. And here we've got a very sensitive Excel spreadsheet that contains all of the password numbers and names for every user in the organization. Why you'd send that by email in the first place, I don't know, but there it is. But potentially that Excel file is compromised. And so as you're scrolling through this file, Carbon Black will detect that there is some malware. So what will then happen is that Carbon Black will report this back to Workspace ONE. So Workspace ONE then reports, well, look, we've got 2,500 compromised devices. Carbon Black has flagged them up. We can see where they are. We can see, in this case, we've got a massive ransomware attack currently ongoing. So you can create a ransomware automated task. So when the platform includes, when the platform's Windows and the threat type is ransomware, then what we're going to do is deploy a patch. We're going to automatically approve the patch in this case. We're going to send an email to the end user. We're going to create an incident, and then we're going to deploy that patch to the end user. And that's how we integrate with these third parties. So we'll use the third parties, we'll use the integration, and then that gives us the capability. So if we have a look at what happens here, Carbon Black has flagged up that there's a vulnerability, and then using Windows Defender, we have automatically pushed out changes to these machines, which means this particular piece of malware can no longer write to the specific location that it was writing to. And obviously, using our partner network, our trust network, and using integrated Windows tools, we'd get that piece of malware completely removed. So hopefully you can see that Workspace ONE is a fully zero trust environment, and using Workspace ONE gives you the ability to secure your employees, to have a look at their activities and their behavior, to secure applications and prevent data being removed from those applications, to completely secure every endpoint, so to be able to apply compliance policies and security policies, and also to ensure that any network that your users are accessing only doesn't lead to compromised data or compromised applications or compromised users. Now, we appreciate that moving to the digital workspace is a journey, and a lot of our customers are at different stages of this journey. And this is why we have a whole model of how you would migrate, how you transition to the digital workspace. So, are there any questions?